Greetings, students. This is a video on Chapter 5, Introduction to the Time Value of Money. So let's jump right into it. So there's some things we'll talk about here: future value and compounding, present value and discounting. Think of the opposite of the first one. More about present and future values. So one of the problems faced by a financial manager is how to determine the value today of cash flows generated or expected in the future. So, time value of money refers to the fact that a dollar in hand today, if you have a dollar right now, is worth more than a dollar in the future. Think about why, because if you have it now, you can go invest it, save it, right? And you can get a return on your money, which increases the value. So that's the idea of this future value. Okay, so future value refers to the amount an investment is worth after one or more periods. So a period could be it could be a month, could be a quarter, it could be more likely a year. The simplest case is a single period investment. So let's start off with an easier example. Suppose you invest $100 in a savings account that pays 10% interest per year. So how much will you have in 1 year? So in general, if you invest for one period at an interest rate of R, your investment will grow to 1 plus R. So think of 1 as what you invested, R as the extra money you get. So R in this case is 10%. So if you invested 100, we just multiply it by 1.1. So R, of course, is 0.1, and we would get the 110. What if you invest for more than one period? Because this scenario, of course, is more likely. So let's get back to the $100 we were just talking about. What will you have after 2 years, assuming the interest rate doesn't change? So then you would have 110 times zero point 0.1, which is $11 of interest during the second year. So the total is, of course, the 110. Add in the $11 of interest, and we get 121. So 121 is sort of think about that like the end of what it'd be worth at the end of year two is the future value of the $100 that you invested at the beginning in 2 years at 10%. So now we're earning interest on interest, right? This is what we call compounding. That's the process of accumulating interest on an investment over time to earn more interest. So think about it like interest upon interest. So compounding the interest means earning interest on interest. So we will call the result compound interest. If you earn simple interest, then the interest is only earned on the original principal amount. In this example, it was 100. So the general formula for future value is this. We can also use Excel for this. We can use calculators, financial calculators. There's many different ways to do this. So the future value of a dollar invested for T, think about T for time, periods at a rate of R per period is as follows. Future value equals what the dollar times 1 plus R to the power of T. Okay, so the expression 1 plus R to the power of T is also called the future value of the interest factor or just the future value factor. For a dollar invested at R% for T periods, we will sometimes abbreviate this where it says FVIF. Okay, so going back to our $100 investment, what will you have after 5 years, assuming the interest rate doesn't change? There's nothing difficult about what we're doing here. It's just we're just literally plugging in numbers, right? So if you see 1 plus R to the power of T, so 1 plus 0.10, that's the 10% interest, and it's for 5 periods, so to the power of 5. Simplified is 1.1 to the power of 5 equals 1.6105. So your $100 will thus grow to 100 times that multiplying factor here, this FVIF, 1.6105. So we get 161.05. So here you're seeing kind of how this would grow over time, right? Like the 100, we start off with 100, and it's always earning, if it's just simple interest, it would just always be 10, because remember the simple interest is just always compounded off or multiplied by that first year's number, the 100. But for compound interest, you see how it grows, right? It's growing, it's growing, it's going to make you more money because it's earning interest on interest. So future value factors. So future values depend critically on the assumed interest rate, particularly for long-lived investments. Okay, so there are several ways that we can do this. So in the last one we looked at, we could have just multiplied the 1.1 by itself 5 times over for the 5 years or 5 periods. But that gets very tedious. If you've got to do that for like 30 years, 50 years, imagine doing 1.1 times 1.1 like 30, 40, 50 different times. You're easily going to get muddled up, right? So calculators generally have a key labeled y to the power of x. So you can enter 1.1, press that key, enter 5, and then just press the equals key, and it'll just spit out the answer for you. You can also use a table. This is what a lot of people use, these tables. that contain the future value factors. The tables are in the book for some common interest rates and time periods. So like below. So the way you use these tables is we look at the number of periods, we look at the interest rate. So if we were saying it was like 4 periods of 15%, just match it up and we get the 1.7490. Now, as far as the calculators go, if any of you are using calculators, and you are free to use calculators, you can use Excel. There's plenty of tutorials on YouTube as far as how to use Excel. It's very easy. The keys you're going to want to pay attention to, FV is future value, what's it worth in the future. PV is present value, what is it worth right now. I over Y is just the interest rate, that's what we've been calling R up to this point. And then N is the number of periods that we've been calling T. So the things you should do just one time. Make sure your calculator is set to display many decimal places because sometimes the numbers go all the way out. Set your calculator to assume that only one payment per period or per year. If the problem tells you otherwise, then you can change it. But if it doesn't, then you can always assume that it's just compounded once per year. And then make sure your calculator is in what we call end mode. I won't go into that right now, but just make sure it's set for end mode. Now, the things you need to do every time you work a problem, before you start, make sure I can't stress that one enough, completely clear out the calculator. Because if you've got stuff in there from the last one you worked, it's very easy to get it muddled up. You mix the information together and you get the wrong answer. If you've got cash going out, put a negative in. Think about like cash is leaving you, so it's a negative. And make sure you enter the rate correctly, like the percent form. So if it's like, 6%, don't put in 0.6, because that would be 60%, right? Put in 0.06. So the effect of compounding. So compound interest. So let's look at an example. So you've located an investment that pays 12% per year. The rate sounds good to you, so you invest 400 bucks. How much will you have in 3 years? How much will you have in 7 years? At the end of 7 years, how much interest will you have earned? How much of that interest is going to result from compounding? So based on our discussion, we can calculate the future value factor for 12% and 3 years as follows. So you can see what we're doing here, we're just plugging in the numbers, right? Remember the formula, 1 plus r to the power of t. So it's 1.12. The 0.12 is representing the 12% interest rate. The 3 is representing the 3 years. So the factor is the multiplication factor, if you will. The FVIF is 1.4049. So then we just multiply the 400 bucks that we're going to invest by that factor, if you will, and we get 561.97. So at the end of, if it stays at 12% for 3 years, it compounds, it'll be worth 561.97 at the end of the 3 years. After 7 years, you'll have 400. So again, you see how we just replaced the 3, we just took this 3 out, put the 7 in, and then we get a factor of 2.2107, again, multiplied by the 400 bucks, 884.27. So basically, you will more than double your money over the 7 years. So because you invested 400, the interest in the 884.27 future value is actually 484.27, right? So think of the 884 as the 400 that you originally invested plus now 484 of interest. Hence why they say that you doubled your money. All right, so let's talk a little bit now about present value and discounting. So present value is the current value of future cash flows discounted at the appropriate discount rate. So like, what is it worth today? So present value is the reverse of future value. So think of future value in the future, present value as like right now, like today. So instead of compounding the money moving forward into the future, now we're going to discount it to bring it back to the present. So to discount is to calculate the present value of some future amount. So the present value of $1 to be received in one period is generally given as follows. And you can see the formula here. I don't need to read that out. We'll look at an example with some numbers here in a second. So the single period case of present value. So let's say that this is a good example being a college student, you need 400 bucks to buy textbooks next year. You can earn 7% on your money. How much do you have to put up today? So what we need to know is the present value of 400 bucks, because that's the future value, right? We need to know what is it worth. If 400 bucks a year from now, what is it worth today? So the discount rate is 7%. So we're just going to take the present value times 1.7, we know is 400. Now we've just got to solve for that. So if we put in the 400 and then times it by 1 over 1.07, make sure you put your parentheses in, correct order of operations, we get 373.83. So what does that mean? That just means that if you want to have the 400 bucks you need next year to buy the textbooks, assuming a 7% discount rate, then we need to invest 373.83 today. All right, so what about, and this is more realistic, more likely, what about the present value for multiple periods? So the present value of a dollar to be received t periods, think about t as time, into the future at a discount rate of r is, and again, we've got this long formula. They always make it a little more difficult than it really is with these big formulas. As the length of time until payment grows, the present values will go down. Think about why, because you've got more time to get to that future value. So we could say that present values and discount rates are inversely related. Okay, so discount rate is the rate used to calculate the present value of the future cash flows. So what they're saying is the higher the discount rate, the lower the present value, and if the discount rate is lower, the higher the present value. So let's look at an example. So let's say that you need to you need $1,000 in 3 years' time. So you can earn 15% on your money. How much do you have to invest today? In other words, what is the present value of 1,000 in 3 years' time at 15%? So we need to discount 1,000 back 3 periods at 15%. So think about 1,000 in the future, back 1 year, back 2 years, back 3 years, that's today. So the discount factor is 1 over 1 plus 0.15. That's the interest rate, right? 15%, 3 periods, so to the power of 3, and we get 0.6575. Then we just have to multiply the 1,000 by the factor, the 0.6575. So we get 657.52. So what they're saying is that if you want the 1,000 in 3 years, assuming a 15% discount rate, today, right now, the present value of that is 657.52. And then there's some little information down here as far as if you want to put it in on the calculator. All right, so a little more about PVs and FVs. So the present value factor is the reciprocal of basically the 1 divided by. So the future value factor is 1 plus r to the power of t, as we established. The present value, the reciprocal, is just 1 over 1 plus r over t, right? So the formulas are very similar. You just got to remember for the present value, it's just 1 over. It's basically the reciprocal. So if we let the future value stand for the future value after t periods, the relationship between future value and present value can be written as one of the following. And these are really interchangeable, if you will. So determining the discount rate. So we often need to determine what discount rate is implicit in an investment. So we can do so by looking at the present value equation, right? So we've got 4 parts of the equation, right? We've got the present value, we've got the future value, we've got the discount rate R, and then we've got the life of the investment T. So as long as we know 3 of these, we've got to know at least 3, we can always figure out the 4th one. So let's look at an example of that. So you're considering a 1-year investment. If you put up 1,250 bucks, you will get back 1,350. So they're telling you the present value and the future value. The question is, what rate is this investment paying? So first, in the single period case, the answer is fairly obvious, right? You are getting a total of 100 in addition to your 1,250. So the implicit rate on the investment is just 100 divided by the 1,250, and we get 8%. So that's, if it's a single period, that's pretty easy, right? More formally, from the basic present value equation, the present value, i.e. the amount you got to put up today, the 1,250, future value is 1,350. The time involved is 1 period. So we have the 1,250 equals 1,350 over 1 plus r to the power of 1, because it's 1 time period. Plug in your numbers, and then it spits out the 1.08. Okay, so in this simple case, you didn't really need to go through all that. It's very simple, right? It just gets a little more complicated when you're dealing with more than 1 time period, which you almost always are. So assume we're offered an investment that costs us 100 bucks and will double our money in 8 years. So we're going to go to 200, right? So present value 100, future value 200. To compare this to other investments, we would like to know what the discount rate, that is the rate of return, is implicit in these numbers. So the present value is 100, future value is 200, so we're going to double our money in 8 years. So to calculate the return, we can just write out the equation again. So 100 equals 200, plug in what you know, right? 1 plus, we don't know r, that's what we're trying to figure out, the rate, and then it's 8 time periods, so to the power of 8. So you could also write it as 1 plus r to the power of 8 is 200, and then over 100 equals 2. That's the reciprocal kicking in again. So if we use a financial calculator, we would just plug in the present value as minus 100 because it's money going out. You're investing money going out. The future value is 200, n is 8 for 8 periods, and then we just solve for what? So we solve for the I over y, which is the interest rate, and we get 9%. So you can do it either way. As it shows you, there's really 3 different ways. There's actually more ways than this that we could do this. But if you put it in on a calculator or if you use Excel, it's going to solve it for you, and it's going to tell you that the answer is 9%, 0.09. All right, so solving for the discount rate. Let's look at another example. So in his will, Benjamin Franklin, no less, gave £1,000 sterling to Massachusetts and the city of Boston. He gave a similar amount to Pennsylvania and the city of Philadelphia. After some legal wrangling, it was agreed that the money would be paid out in 1990, 200 years after Franklin's death. So by that time, the Pennsylvania bequest had grown to about 2 million bucks. The Massachusetts bequest had grown to 4.5 million. So if £1,000 sterling was equivalent to $1,000, what rate of return did the two states earn? So for Pennsylvania, the future value, of course, is 2. The present value is 1. There are 200 years involved, so we need to solve for R in the following. So again, a lot of what, and you're going to see this, a lot of this stuff, guys, is just plugging in numbers, just making sure you plug them in the right places. 1,000 equals 2 million over 1 plus R to the power of 200. So you can see 1 plus R to the power of 200 is just going to give you 2,000, right? So then, if you want to use your calculator, we could say, or Excel, n equals 200, number of years. Present value, put that in as a negative, negative 1,000. And the future value is 2 million. So then we solve for the interest rate, and we get 3.87. All right, so here's a kind of a facetious example, right? So you want to retire in 50 years as a millionaire. If you have 10 grand today, what rate of return do you need to earn to achieve your goal? So the future value is a million, so that's when you want to retire, right? Present value today is 10,000. We got 50 years. So again, just plug in your numbers. So we've got the 1 plus R, we put in our 50, and we know that this is 100. So the future value is 100. So you can verify that the implicit rate is about 9.65%. Let's say that we want to purchase an asset that costs 50 grand. So we currently have 25 grand. So we basically need to make the extra 25. If we can earn 12% on this 25,000, how long until we have the 50,000? So this is more of a T question, right? Like time. So looking at the equation, we can plug in the present value is 25,000, future value is 50, the interest rate is 12%. So the basic equation takes one of the following forms. You can do it either way. So probably the top one is easier. 25,000 equals 50,000 over 1.12 to the power of t. Okay, so we have a future value factor of 2 for a 12% rate. So we now need to solve for t. So if you look at the table, 8.1, you will see that a future value factor of 1.9738 because at the intersection of 6 periods, that's on the vertical axis, and about six, so it's about 6 years. So to get an exact answer, we could use the financial calculator, just plug in your numbers, interest rate 12%. Present value, again, put it in as a negative, 25,000. Future value, just leave that as a positive because that's coming back to you, 50,000. And we get n equals 6.11. So just say just a little over 6 years. Just say like 6 years in a month, roughly. Okay, last example. So you've been saving up to buy the Godot company. The total cost is 10 million. You currently have about 2.3 million. If you can earn 5% on your money, how long will you have to wait? So at 16%, how long must you wait? So at 5%, you'll have to wait a very long time from the basic equation, right? So 2.3 million equals 10 million to the power of 1.05. Again, that's the interest rate. And t to the power of t, the exponential is what we're trying to solve for. So 1.05 to the power of t equals 4.35. So thus t must be equal to 30 years. Now 16%, it gets a little better, right? Think about the higher interest rate, it's going to get there quicker. So verify for yourself that it will take about 10 years. And again, you can just do that from, you can just rearrange what you see up here. Take out the 0.05, replace that with 1.6, right? And then solve, and then basically just solve for t. And it'll be right around, it might not be exactly 10 years, but it will be right around 10 years. Okay, that's it for this chapter. If you have any questions, please feel free to reach out. Talk to you guys soon.